Welcome to PCB Chat, where we talk with experts across the printed circuit design, manufacturing, and electronics supply chain fields. I'm Mike Buteau, Editor-in-Chief of PCD&F and Circuits Assembly. My guest today is David Bernard. David is an X-ray consultant for the electronics industry, with more than 20 years' experience in the use and understanding of X-ray inspection and test. He is the original author of A Practical Guide to X-ray Inspection Criteria and Common Defect Analysis. David has a Ph.D. in chemical physics from the University of Sussex in the UK. Now, next month, David will present a 3-hour webinar on X-ray inspection. The title is Getting the Best from Your X-ray Inspection System. David, welcome to PCB Chat.
Thanks a lot, Mike.
Now, you've been a columnist for Circuits Assembly for a few years, and in that time, you've covered quite a range of issues related to inspection. Over the course of your career, have you noticed any particular changes in the understanding of how X-ray can be used in electronics inspection?
I don't know about understanding. People know why they want to use it, and that is to see those features in their boards that are optically hidden from view. They have no other way of checking to see if reflow, for example, has happened correctly and appropriately. In my seminar, Getting the Best from Your X-ray Inspection System, I've looked at all the equipment that is out there and tried to understand that the X-ray inspection systems that people have vary widely, both in terms of age and capability. So when you're doing inspection, you know what you're trying to inspect, but what the X-ray machine can achieve may be very different from site to site. And as a result, I wanted to try and offer a seminar where it would ensure that people understood the capabilities of their X-ray inspection machine, so that when they come to doing the inspection of BGAs, QFNs, connectors, low temperature solders, plated through holes, and everything else, they know what their system can do, but also what it may not be able to do, so that when I then present some suggested methodologies to inspect these features in what I hope is a practical, step-by-step approach, they can do it to the best of the ability of the system. And if it can't achieve all of those functionalities, then stop while you're ahead, do some X-ray rather than none, and I hope offer the benefit to the manufacturing process in terms of the quality that will come from the manufacturing process.
So that's a great point. Just as a rule, some X-ray is better than none.
Yes, if that's my one thing, don't compare it with optical inspection. Optical inspection, it's complementary. It's important. X-ray has its own benefits and opportunities because it can see stuff that you can't see optically. But some X-ray is better than none. But that some X-ray is going to vary depending on the equipment you have. And if you don't understand what the limitations of the system you have are, then you may be trying to push it into areas it can't achieve. And not only are you failing what you can provide as a service, but it may cause you problems because you won't be able to see the potential flaws that the rest of your organization is hoping you'll pick up, obviously on the assumption that people occasionally have problems. I'm sure that's not the case for your audience, but we have to take a view.
Are you going to be addressing questions from the audience?
Yes, absolutely. There is a technical part of it to make certain people understand what the X-ray machine contains. It's not highly technical. I hope there's sufficient graphs and things like that just to make certain that there's an understanding. And then after that, it's going through the methodologies for the different types of components as far as people can achieve.
Will your webinar be covering both 2D and 3D inspection?
I'm going to be looking primarily at what you would call offline 2D X-ray inspection, but it will include information about laminography and CT, and also information about inline and automated X-ray inspection. They're both 2D and 3D. Not so much in terms of detail compared to the manual offline, but all the problems that you have in manual offline are going to be there for inline and 3D applications, but with more, and I've tried to address those at some level.
I should also clarify, the seminar is not tied to any specific brands of equipment, correct?
Absolutely. It's designed to be non-commercial. I'm not going to recommend one machine over another because at the end of the day, I hope this is a practical seminar so that people can use what they have, whatever the machine. Of course, I'm going to be showing pictures and examples, but they're going to be illustrative rather than of one specific machine or another. The information I have is from published sources, so it's what's out there. And I'm deliberately not naming or even shaming people because that's not fair and not reasonable. And it is also more practical that I'm trying to show a range of the capabilities that are out there so that people can realistically see where their system is in the spectrum of what is possible. And I'm not going to say what you should and shouldn't have, but I think it is important, for example, magnification being one of the most important things, in my opinion, is that if your machine, for the reasons that I'll expand in the seminar, can't get to the magnification you need to achieve, then don't waste your time trying to do it. But if it's good enough for some of the tasks, you should use it because it's going to give you that valuable information that you won't see optically.
Now, in the webinar, which I should mention takes place on May 20th from 1 to 4 o'clock Eastern Time, you did mention a moment ago the low temperature solders. I don't want to give away too much, but what is it about LTSs that makes them perhaps a little bit more tricky when it comes to inspection?
Sadly, or rather not sadly, from an X-ray perspective, and without giving the whole game away, they don't make a great deal of difference from an X-ray perspective, because what you're trying to do is look at material, and the X-ray sees more dense materials better than less dense materials. And although they're low temperature solders and they're the benefits of their operating temperature, of course, why people are very interested in using them, in terms of physically seeing them in the X-ray machine, they are very dense and so don't look any different as joints compared to traditional lead-free or even tin lead solder joints. You're going to see the same problems in low temperature solder as you would in any other solder. The fact that it's being created at a lower temperature from an X-ray perspective doesn't make any difference.
So it's really all about the contrast and the density.
That's exactly right. It's to do with the contrast, and the contrast of low temperature solders is equivalent to lead-free solders or tin lead solders. So you can see the same problems even though it's a different material.
I see. And who should attend the webinar? Like, who's the target audience?
I've tried to aim it at those who are new or relatively new to X-ray inspection. And so we'll offer them some tips and guidelines about how to start investigating the most commonly analyzed components and features that they're going to come across on a day-to-day basis. But I also hope that it provides a training resource for the more experienced users who are going to be responsible for training the next generation and training new people in a continuing professional development way to investigate features using X-ray so that it can be done to the best of the system's capabilities and therefore provide the best functionality within the manufacturing process. There's also a possibility that for those people who are considering replacing an existing X-ray machine, then I hope it may also provide additional information to what's out there and the questions they may need to ask in order to get the best system for their use.
Would you say that the presentation emphasizes more theoretical, or is it more aimed toward the practical application?
It's both. In the first part, it's going to be more of a technical discovery and explanation of the X-ray system and the various components in order that people will understand how it can achieve the magnification it does, how it can achieve the sensitivity in grayscale that it can, and the ability to do laminography or CT if and when that's appropriate. So that's the first half in terms of understanding what you have, and then to put that in perspective of how you're going to use it. And then the second half, I've tried to give practical examples and methodologies of suggested ways of inspecting the most commonly investigated objects, such as BGAs, such as QFNs, connectors, plated through hole that I've mentioned before. And I hope together that will provide some useful information, with the proviso that there may be people using equipment that may not be able to achieve all of the steps in the suggested method, but of course to do as much as they can and then not waste time doing things that their system, for whatever reason, just can't achieve.
Okay, well, thank you, David, for coming on to PCB Chat and giving us a little bit of a insight into your upcoming webinar that takes place on May 20th. The title is Getting the Best from Your X-Ray Inspection System, a 3-hour webinar available at pcb2day.com. And just a note that anyone who pre-registers will have access to the webinar for 30 days on demand following the May 20th presentation. So a big thank you to my guest, David Bernard. For more information, you can email David at dbc@bernard.abel.co.uk. For PCB Chat, this is Mike Buteau. Have a nice day.